Hello, my name is Ryan from Buster Beagle 3D. Today I'm going to show you how to laser engrave a better looking round logo on a cylindrical or tapered object. I'll be using my XTool D1 with a rotary attachment, and I'll show you how to achieve this with completely free software. So let's get started. So the first thing I'll show you is how to adjust a round image on a cylindrical object. As you can see, if you take a perfectly round circle and apply that to a cylinder, it makes the round shape look oval. This is just an optical illusion. If you measure the logo, the values are perfectly circle. Now there are specific calculations you can find online, like that of the arc length, that you may see some people in the Facebook groups talk about, but I find that those calculations make the round image slightly oval in the horizontal aspect ratio, so I find them a bit too extreme. It may look fine when you're viewing the object dead center, but since you won't always be looking at it like that, I would suggest stretching out the value by around 10%. So if you see here in Laserbox Basic, I've imported this raster image. Now the same thing would apply if you were using a vector image. So I just went to Menu, Import, and it brought this logo in. So right now the size is 384 millimeters. So I want my logo to be 65 millimeters. I'm just going to zoom in here. So now for the logo on just a plain cylindrical object, all I want to do is stretch in the horizontal or the width by about 10%. So I'm going to click this little lock right here, and then I'm going to change that 65, and I want to increase that by 6.5 millimeters, which is 10%, or 71.5 millimeters. And then that's all you have to do. So this is what I'm going to burn onto my glass or tumbler or whatever else that is a pure cylinder that I want to attach this to. So I would just click that. I'm going to transform that 90 degrees, and then I'll move on to the next step. Now if this is as far as you're concerned about it, you're just doing a perfectly cylindrical object, you can look in the timeline and skip over until we get to the part where we're going to calibrate our rotary attachment for the laser. But if you want to see how I would do the same thing with a tapered mug or glass or tumbler, then we'll move on to the next part. If I open up Photoshop here, you can see that I have this logo in there. Now I'm going to show you how to adjust this without Photoshop, because Photoshop is a paid program that maybe not everyone has. So there is another browser program, and it's called Photopea. And if you are familiar with Photoshop, this will all look very familiar to you. And this is completely free. It's not an Adobe product, but you'll see once I open it how similar it seems to Photoshop. So I'm going to open that image. And, you know, if I didn't tell you that you weren't looking at Photoshop, you would probably think you were. But this is all in the browser, and it's got ads on the side, which I guess is how they pay for this. So what we want to do is we want to taper this circle before we get into the point where we stretch it to be on a tapered glass or whatever else. So the first thing that you want to do is you want to figure out what angle we need to adjust this based on the glass or whatever that you're trying to do this to. So I need to find the angle of that cup. Now you can use something like this multi-square here that I had from Harbor Freight, and you can figure out, and you can put that up against the glass, and you can figure out the angle that way. There's also apps that you can get on your smartphone that are levels that you can use, the gyroscopes in your smartphone to figure out the angles. Now if you don't have either of those, there's a couple other ways. So the first way would be to use a taper calculator. So what we're going to need is the diameter of the top of the glass and then the diameter of the bottom of the glass. Now you can just take a ruler and you can measure just straight across the top if you want, and then straight across the bottom if you want. Sometimes it's a little bit hard to find the exact center of a circle when you're doing that. Now there is another way to do that. It's a little bit more math-centric, but I can show you that right now. So what you want to do is you want to take a measuring tape and you want to measure the circumference of the top of the glass. So in this case it's 280 millimeters. And then you want to take the circumference of the bottom of the glass, and that is 200 millimeters. And so a little bit of math that we probably skipped over in school, but it's how to calculate the diameter from the circumference. So you take the circumference, and I will just open up a calculator in Windows here. Now if you just have the regular standard calculator, you can come up to the top here and turn on the scientific calculator, because we need this pi value. You can also just use 3.14 for pi, but anyway. So the top of the glass, the circumference is 280 millimeters, so I'll do 280. And you want to divide that by pi. And this number here is the diameter of the top of our glass, so it's 89.12. And then I am going to do the same thing for the bottom. So I will do 200 millimeters divided by pi. And we have this 63.66. And then I also measured the distance of the entire cup, which was 150 millimeters. So the major diameter, which is this top one here, was that 89.12, and the minor diameter was 63.66, and then the length of the cup or taper was 150. So right here we see that our taper angle is this 4.8 millimeters. So what I want to do is I want to go back into this Photopea program, and what I want to do here is make the bottom angle out that 4.82 degrees. The thing that you don't want to do is just do a perspective of the 4.82 degrees, and I'll show you what I mean. So if I hit Control A and select everything, and again, if you're familiar with Photoshop, this is all identical, and then I'm going to go to Edit. So I'm going to show this transform and then perspective first, just to show you what I mean. So if I was to take this, and I'll do it a little bit more extreme, you see the further I go in with that taper, the wider or larger it makes the text at the bottom and smaller at the top. So you would be altering the image itself and not just kind of shrinking in or widening out the bottom if we do it this way. So what you want to do instead of perspective is you want to come to Edit, Transform, Warp, and then you can see that we're now in this warp image. And so I'm going to come up here to None, and I'm going to change that to Arc, and then come over here to where it says Bend, and I'm going to change that to 0. And then over here where it says V, and it was noticed by a buddy of mine, Michael Stevenson, that this is a percentage and not an angle. So the closest calculation that I could come up with that will convert this percentage into the angle that we're looking for would be the angle that you got in the last step times 2 minus 2.22. And so you'll notice that for the 4.8, So the 4.8 times 2 minus the 2.22 is 7.38. And you'll see that it rounds the number anyway to 7, so it'll either round it to the closest number, either up or down. So this isn't an exact degree, but it's really, really close. And I've run the calculation on multiple angles, and it's the closest calculation I can get to the to convert that percentage to the angle that we're looking for. Now you see that it has pulled in the top and then pulled out the bottom that 4.82 degrees on both sides. So this will compensate for the taper, so as it goes down and there's basically less real estate on the bottom of the glass, it's going to print more on the bottom of the glass than it would on the top, and that compensates for that taper. So then I'm just going to press enter, and at this point I'm also going to add that 10% that we were adding for the cylindrical objects that we did when there was no taper. So you can just come up to image and then image size, and then I want to change pixels to millimeters, and you can see it's 65, and this little icon here is keeping that aspect ratio consistent, so I don't want to do that, so I'm gonna uncheck that box. And then here I want the width to be the same width as I did in that other step. And you can do this step in Laserbox Basic or whatever program that you're using. I'm just going to do it here. So 71.5. And then I'm going to hit OK. And so this is the image that I want to burn. So if you want to save it, you can just click this PNG button and it'll save a PNG of this object. And I save that. And so now I'm going to come into Laserbox Basic, and I'll just show you the difference between the two. So I'm going to import, and I'm going to find that in my downloads folder. Okay, so right here it came in very large, and you can see that it's not a square anymore because we've scaled it in the other program. So you can see that there's a little bit of space on the side here between the end of the logo and the end of the bounding box. So we want to make sure that when we're scaling this down, we're scaling down the from the height, because we know that that stayed consistently. You can see that the line goes right up to the edge of the logo, so we know that that's still correct. So I'm going to change this to 65, and you can see now it's changed that other one to the 75, because it's also taken into account some of this white space. And then I'm just going to rotate that by 90 degrees. And there you can kind of see the difference between the two of these. So on the right here would be the logo on a perfectly cylinder object, and then this would be the logo on a object that is tapering down. So at this point I also kind of just want to mention that before you go on to the next step where you want to burn this on your tumbler or mug or glass or whatever it is that you're doing, I would really highly suggest printing these out either from this program or whatever program you're using. Print it out on a piece of paper first, and then put it on your glass or tumbler or whatever. Don't use your what could be expensive item to test out your design first. You really want to kind of print this out to verify that everything looks okay first before you ever go to any type of burning on the actual object. Okay, So the next thing that we want to do is calibrate our rotary attachment that we're going to use to rotate the glass or mug or tumbler on the laser. Now I'm going to be using the XTool Rotary Attachment 2 Pro, and depending on which roller or chuck you're using, which position you're using for those things, it might not be turning it the exact value that you think it is. So what we're going to do is I'm going to come up here to the device settings, and I want to make sure that I have laser spot turned on so that I'm not using that crosshair anymore, because I'm going to measure something with this laser spot. I'm going to hit save. And now I'm going to hit the start or press F6. Now, what I want to do is I want to test to see how far the laser goes given whatever setup I use with the rotary attachment, and make sure that it's moving in the same distance that I think it's supposed to be. So I'm going to move the speed all the way down to 5. And then I'm going to change the distance in millimeters to 100 millimeters. And then I'm going to come down here to cylinder working and click that on. So then what I'm going to do is I'm going to turn on the laser spot at this 3%. And you want to put your glasses on for this. And then on the glass, I'm going to put a little mark where the laser starts. And then I'm going to press this bottom arrow key, and then the cup is going to move, and then I'm going to put another little mark. And then what you want to do is you want to measure the distance between those two marks. And right now I'm assuming that that distance is 100 millimeters. But when you measure that distance, you'll see that the distance is only 90 millimeters. So what that means is when I think that when the laser thinks that it's supposed to be moving 100 millimeters, it's only moving 90 millimeters. And this number will change based on whether you're using the wider rollers, the middle rollers, or the chuck. All of those values will be slightly different. So now that I see that it only moved 90 millimeters and it was supposed to be 100, I know it's 10% short. So I'm going to cancel this. And I'm going to come back to my logo, and if I printed it just the way that it was, it would be 10% short on the horizontal. Well, it's turned to the side, but what would have been the horizontal. So I want to add another 10% to this value. 10% of 75.8 would be 7.58. So if I do my calculator, I would do 75.8 plus 7.58, and you'll see I have 83.38. So I'm going to click this little checkbox or the little lock again, and then do the 83.38. And so that has now widened the logo even further. So now when I go to burn this, the extra size that I just put in there should compensate for the 10% that the rotary is not turning the way that it should. Now if you're using light burn, there are other things in the rotary settings that compensate for this, but since I'm using Laserbox Basic with my XTool laser, that is the compensation that I have to factor into my image. So the last step that I'm going to do before I burn, because I'm going to be burning on this glass that I just picked up from the dollar store, I'm going to coat the glass with a tempera paint, and shout out to Kobe Schmidt that you've undoubtedly seen in the Facebook groups for coming up with this method. So what I'm going to do is dilute the tempera paint slightly, and then I bought this really cheap $10 airbrush set from Harbor Freight, and I'm going to spray the outside of the glass with this tempera paint that's been slightly diluted. It takes about half an hour to dry. It'll dry very, very quickly. And then I'm going to go for the 100% power at 20 millimeters per second. I want to do this all in one pass, and then I'm going to turn my sharpness all the way up to 100%, and that is what I am going to engrave onto my glass, and let's see how it turned out. So again, using Kobe Schmidt's method of using the tempera paint, it washes off super quick and easy, and you can see that it does a really nice job of getting a nice consistent engraving on the glass. So that's it. That's my method for engraving on a cylindrical or tapered object. If this was useful to you, please do hit that like button and consider subscribing to my channel for other things dealing with laser engravers, 3D printers, CNC, and injection molding. And we will see you guys next time.